Okay, let's look at an example that they have in the book here of how exactly do we use this information about set theory. Now, how is that going to help us with this example? Okay, so it tells us here numbers chosen from the set of positive integers from 1 and 8, between 1 and 8 inclusive. A is the set of odd numbers between 1 and 8, and B is the set of prime numbers between 1 and 8 inclusive. So they ask us to set the sample space. Question A, part 1. Now if we have a look at the sample space, okay, they've given us all of the positive integers between 1 and 8 inclusive. So 1, 2, 3, 4, 5, 6, 7, 8. Now, for the set of A, we're talking about the set of odd numbers between 1 and 8. So the odd numbers, we've got 1, 3, 5 and 7. They're the odd numbers. Now B is the set of prime numbers between 1 and 8 inclusive, and since 1 is not a prime, we have 2, 3, 5 and 7. Okay, so all the prime numbers where 1 is not a prime. It tells us to draw a Venn diagram, and so what we're looking at here is the elements of each. How many elements are in each set is what we put in here. So in set A we have 4 elements, so 1 and 3 will make 4 elements making up the set of A. And in set B we also have 1, 2, 3, 4, so the elements in set B will also make up 4. Now 3, 5, 7 occurs in both sets, so 3 elements are common to sets A and B. And if we have a look at our sample space, we have 3 elements that are not odd numbers or prime numbers. Okay, and those numbers are going to be the ones that are not in here, such as 4, because we have 1, 2, 3, there's no 4, so 4 is not in it. We have a 5, there's no 6. We have a 7, there is no 8. So this number 3 represents the numbers that are not part of the odd or prime numbers. Now it asks us to list some sets. So if we go and have a look and remind ourselves using the information that we're given what each of these things represent. Coming back to our question now where we have to list the sets for A intersection B, which tells us they're common to both A and B. Okay, we have the numbers 3, 5 and 7. If we look at our sets up here, 3, 5, 7 are in both sets. They're the common. So that's the set that you would list, and you write it just as it's written here. A union B, okay, is going to be the numbers that are in either, or the elements in either A or B or both. Okay. Here we're looking at A prime, which means it's the complement of set A, which means the elements from the sample set, which is all the positive integers between 1 and 8 inclusive, which are not in set A. So set A has 1, 3, 5, 7, and that simply means any of the numbers from here that are not in that set. And as they've identified here, it's 2, 4, 6 and 8. As we look now, the last set for this question is B only, and what that means is the element that is not in set A or B, so it's not in the intersection but it's in B only, that's one element, and they tell us here it's 2. as we can see by comparing the sets. So the final section of the question is asking us to find this symbol here, which means n of A is the cardinal number, which means how many elements are in set A. In this case we have 1, 2, 3, 4, so n of A equals 4. The probability of A occurring, if you were to randomly pull any number, okay, as it tells us the chance that an element will belong to group A out of the sample space. There's 4 numbers in A compared to 8 in the sample space, so we put how many elements are in set A over the sample space, and we end up with a simplified fraction of a half. 1 chance in 2 of pulling out an element from A. Final question is the number of elements in A intersection B. We can read off our Venn diagram. It's 3. The last section is what's the probability of getting the intersection, which we would simply write as 3 over 8. Let's have a look at some of the language that they use for set theory. So first of all, we've got our sample space, okay, and that, as it says there, it's the list of all possible outcomes. Okay, and then it tells us some of the various things that it can be represented, the various symbols. But our sample space is the list of all possible outcomes. Okay, so in our example here, the sample space they give us here is the numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now, when we talk about the next section, we're talking about subsets, and they use this symbol here to illustrate a subset. And they say A is a particular subset of the sample space if all elements in A are contained in the sample space. So in other words, if the number meets the conditions that defines A, it's in the set. So they tell us, for example, A is the set of prime numbers less than or equal to 10, and that means that it's the subset of all integers less than 10, which is a subset of that. So A in this case is the prime numbers, and we have 2, 3, 5 and 7. Now, A prime, this little tick, okay, is called the complement of A. Now if you think of complementary angles, okay, it's the two things that add up to an angle's size. So in this case, we're talking about the two things that add up to create the sample space. So in this case, if A is the subset of prime numbers, is the set of prime numbers less than or equal to 10, A prime are the elements that are not in A. So that's going to be the numbers that are not primes but are less than 10, and they're over here. 1, 4, 6, 8, 9 and 10. Now this symbol here, 5 with like an E put on its side, or a round E is called 5, is an element of A. Okay, so 5 up here is part of the set of A. Okay, so this symbol here, which is like a little hill, okay, means A and B, which means the intersection of A and B. If we think in terms of the Venn diagram, it's the part where the circles cross over. A and B means the elements that are in both sets A and B. Now, as they tell us in this example, that is 3, 5 and 7. AUB means A or B, which means the union of A and B, and includes the elements in either A or B or both. So in this case, it's going to be the elements in A, 2, 3, 5, 7, which are down here, and the elements in B, which is 3, 5 and 7 plus 1 and 9, which are down here. So that would include both circles in our Venn diagram.